Here formaldehyde reacted with 2,4 dinitrophenyl hydrazine, it will form formaldehyde 2,4 dinitrohydrazone. There is a presence of alpha hydrogen in aldehydes and ketones. Due to that alpha hydrogen, there is a number of reaction could be expected. This cross aldol condensation between aldehyde and aldehyde, ketone and ketone, or aldehyde and ketone. So we'll call it as mixed aldol condensation. Hello everyone, this is Harshita Bhavasar from Vidhyaashram PU College Temple of Excellence. Today I am going to start session 3 from the chapter Aldehydes, Ketones and Carboxylic acids. In the previous session we have discussed about preparation of ketones as well as its physical and chemical properties. In current session we will discuss further chemical properties of aldehydes and ketones. In that, oxidation of methyl ketones, reactions due to alpha hydrogen. Due to alpha hydrogen, some of the reactions we'll discuss. In that, aldol condensation, cross aldol condensation, CANNIZZARO'S reaction, electrophilic substitution reactions, and uses of aldehydes and ketones. This is little bit huge elaborated session, but it is completely important session. Please go through. Condensation reactions with derivatives of ammonia. Ammonia and the derivatives of ammonia react with carbonyl group of aldehydes and ketones to form condensation products. Ammonia and its derivative of ammonia means we know NH3, and its derivative of ammonia will react with carbonyl group of aldehydes and ketones to form condensation products. The reaction is reversible and catalyzed by using acid. These reactions are reversible and by using a catalyst known as acid. The equilibrium favors the product formation due to rapid dehydration of the tetrahedral addition product. It will reach equilibrium very fastly by the formation due to rapid dehydration of the tetrahedral addition product. The net result is replacement of the carbonyl group with cyanide group. Reaction with hydroxylamine means derivative of ammonia, how it will be reacted with aldehyde and ketone. Aldehydes and ketones react with hydroxylamine in weakly acidic medium to form oxines. In the weakly acidic medium, aldehyde or ketone will react with hydroxylamine to form oxine. General formula of hydroxylamine is NH2OH. In the weak acidic medium, it will form oxine. CRRNOH. For example, formaldehyde reacted with hydroxylamine in the weakly acidic medium, it will form formaldooxine. NOH is present, that is oxime. CNOH, it will form formaldooxine. Next, reaction with hydrazine. Hydrazine is NH2, that is a derivative of ammonia. When aldehydes and ketones reacted with hydrazine to form hydrozones. See here, aldehyde or ketone reacted with hydrazine, that is NH2 in the acidic medium, it will form hydrozone CNNH2. For example, formaldehyde when reacted with hydrazine in the acidic medium, formaldehyde hydrozone will form. Next, reaction with phenyl hydrazine. Phenyl hydrazine means NH2NH C6H5 phenyl, so C6H5 hydrazine NH2NH. When aldehyde or ketone reacted with phenyl hydrazine in the weak acidic medium, phenyl hydrozone will form. When formaldehyde reacted with phenyl hydrazine, it will form formaldehyde phenyl hydrazone. Next, reaction with 2,4 dinitrophenyl hydrazine. This 2,4 dinitrophenyl hydrazine will be used while doing organic salt analysis. So, aldehydes and ketones react with 2,4 dinitrophenyl hydrazine, will also called as 2,4 DNP, to form 2,4 dinitrophenyl hydrozones. Okay, this is 2,4 dinitrophenyl hydrazine. 1, 2, 3, 4. So, 2,4 dinitrophenyl hydrazine will form phenyl hydrozones. Here, formaldehyde reacted with 2,4 dinitrophenyl hydrazine, it will form formaldehyde 2,4 dinitrohydrozone. These were the what all we have read now or we have discussed now. Those are the reaction with ammonia or derivative of ammonia with aldehydes and ketones. Next, Clemmensen reduction. The reduction of aldehydes and ketones into corresponding hydrocarbon on treating with zinc amalgam and concentrated hydrochloric acid. Zinc amalgam and concentrated hydrochloric acid will call Clemmensen reduction. Means by aldehyde or ketone, it has to form corresponding hydrocarbon by using zinc amalgam and concentrated HCl. Here formaldehyde will be reacted with zinc amalgam or concentrated HCl. Reduction means hydrogen will be added. Here methane will form. CH2 and hydrogen will be added to become methane. Next, WOLFF-KISHNER reduction. These are the reduction types. The reduction of aldehydes and ketones to corresponding hydrocarbons by heating with a mixture of hydrazine and a strong base like KOH, potassium hydroxide in ethylene glycol is called WOLFF-KISHNER reduction. During this reaction, the carbonyl group is converted into methyl group. In this reaction, the carbonyl group is first treated with excess of hydrazine to get corresponding hydrazone, which upon heating in presence of a base furnishes the hydrocarbon. Here aldehyde, or here you can see the ketone treated with hydrazine. First it will react with hydrazine. Later it will reacted with potassium hydroxide, ethylene glycol and heated. It will form hydrocarbon. Hydrazine to hydrazone it will form. Later hydrocarbon will be formed. Okay, see here formaldehyde treated with hydrazine. Later react with potassium hydroxide in ethylene glycol called methane. This is about WOLFF-KISHNER reaction or reduction. This WOLFF-KISHNER reduction is very much important for the perspective of examination. Test to distinguish aldehydes and ketones. To distinguish about aldehydes and ketones in your qualitative analysis, this test is very much essential, that is tolerance test or silver test we will call. Aldehydes give bright silver mirror on warming with freshly prepared ammonical silver nitrate solution. When the given compound, if you have treated with ammonical silver nitrate solution, the reaction occurs in alkaline medium and ketones do not respond to this test. Okay, aldehyde, ammonical silver nitrate in the base medium or alkaline medium, it will give silver mirror test. Okay, and this test will not respond for the ketones. This is only test for aldehydes. Next, Felling's test. Felling solution is an alkaline solution of copper sulfate containing sodium potassium tartarate. As a complexing agent, aldehydes on warming with Fellings of solution give a red precipitate of cuprous oxide as a result of redox reaction. Aromatic aldehydes do not answer to this test. When aldehyde or any aldehyde or ketone reacting with cuprous oxide in the alkaline medium, red precipitate is coming, means that is aliphatic aldehyde, and aromatic aldehyde will not respond for this test. Okay, in the presence of tartarate or citrate will be used. Here aliphatic aldehydes will be given out its functional property and red precipitate will be formed but not by aromatic aldehydes. Oxidation of methyl ketones or haloform reaction. Aldehydes and ketones having at least one methyl group linked to the carbonyl group at or oxidized by sodium hypohalite. Means one methyl group containing or connected with carbonyl group will react with sodium hypohalite and will get oxidized. It will form sodium salts of carboxylic salt and haloform. Iodoform reaction with acetone. This is acetone. This is iodoform. This is sodium hypoiodide will form sodium salts of carboxylic acid and treated, and it will be byproduct will be iodoform. Reactions due to alpha hydrogen. There is a presence of alpha hydrogen in aldehydes and ketones. Due to that alpha hydrogen, there is a number of reaction could be expected. So, what is that alpha hydrogen, where it is located in the aldehyde or ketone, and how it will be responsible for the further reactions we will see now. In addition to nucleophilic additions, aldehydes and ketones show an unusual acidity of hydrogen atoms attached to the alpha carbon, that is adjacent to the carbonyl group. This is carbonyl group, and adjacent to the carbon, this carbonyl group, hydrogens which are present here Those are all alpha hydrogen and this is alpha carbon. These hydrogens are referred to as alpha hydrogens and the carbon to which they are bonded in an alpha carbon. In ethanol, there is 1 alpha carbon and 3 alpha hydrogens, while in acetone, there are 2 alpha carbons and 6 alpha hydrogens. This is in aldehyde, 3 alpha, 1, 2, 3 and this is 1 alpha carbon, 3 alpha hydrogen. In ketone, that is example of acetone, 2 alpha carbon and 1, 2, 3, 4, 5, 6. 6 alpha hydrogens are present. These alpha hydrogens in aldehydes as well as in ketones will give that number of acidity of hydrogen atoms. Due to this acidity of hydrogen atoms will give number of reactions. The aldehydes and ketones undergo number of reactions due to the acidic nature of alpha hydrogen. The acidity of alpha hydrogen atoms of carbonyl compounds is due to the strong electron withdrawing effect of the carbonyl group. That acidity of alpha hydrogen atoms of carbonyl compounds is due to the strong electron withdrawing effect of the carbonyl group. Due to the carbonyl group, there is a strong electron withdrawing effect and response for the resonance stabilization of the conjugate base. See here, it will having electron withdrawing group. So, from the base, it will gain some of the electron. Here you can see the resonance effect. After here, it will be having here. So, it will shift to here and from the double bond to oxygen because electronegative element. And see here electronegativity you can observe near oxygen and it will stabilize the resonance also of a conjugate base. And reactions due to alpha hydrogen. Due to alpha hydrogen you can see aldol condensation and also cross aldol condensation reactions. Aldehydes and ketones having at least 1 alpha hydrogen undergo a reaction in the presence of dilute alkali as a catalyst to form beta hydroxyaldehydes. Aldehydes or ketones, if it is having only at least of 1 alpha hydrogen, it will undergo reaction or condensation in the presence of dilute alkali and it will form beta hydroxyaldehydes, which will call aldols also, ketols also respectively. That will called aldol reaction. The aldol or ketol readily lose water to give alpha beta unsaturated carbonyl compounds, which are aldol condensation products, and the reaction is called aldol condensation. This is ethanol, aldehyde treated with dilute alkali, which is a sodium hydroxide. It will form 3-hydroxybutanol called aldol and it is ready to give or lose water molecule and it is but2-enol aldol condensation product. Here propanone in the presence of barium hydroxide gives ketol and after losing of water it will readily form aldol condensation product. It is from aldehyde, it is from ketone. Here you may observe that due to the alpha hydrogen, here also alpha hydrogen is present. We have seen already in aldehyde 3 alpha hydrogen, in ketone 6 alpha hydrogen. Due to this alpha hydrogen, it will form aldol and ketol as well as aldol condensation products in both the way. Next, cross aldol condensation. Aldol condensation is not confined to similar molecules of aldehydes and ketones. That aldol condensation will not confined or will not confirm in all the aldehydes and ketones. So, it can also take place between different aldehydes and ketones. This cross aldol condensation we will see in different aldehydes and different ketones. When aldol condensation is carried out between two different aldehydes or different ketones or between an aldehyde and ketone, it is called cross aldol condensation or mixed aldol condensation. This cross aldol condensation between aldehyde and aldehyde, ketone and ketone or aldehyde and ketone. So, we will call it as mixed aldol condensation. See here, this is both are aldehyde in the presence of base. It will form 2 molecules of ethanol. Here 2-methyl, 2 molecules of propanol. Okay, this is simple and self-aldol products. And it will form 1 molecule of ethanol and 1 molecule of propanol also. So, cross aldol products also you may observe. Okay, this is ethanol and propanol will be formed, and here ethanol and 1 molecule of propanol. This is cross-aldol products can be observed. Ketones can also be used as one component in cross-aldol reaction. This is aldehyde and this is ketone. Here you may expect ketol and trans-calone, that is benzyl acetophenone. Okay, they have told aldehyde, ketone, or aldehyde, ketone. We have seen aldehyde and aldehyde in the previous slide. Here with aldehyde and ketone, you can expect ketol, and next losing of water, trans-calone or benzyl acetophenone can be expected. Next, CANNIZZARO'S reaction. The aldehydes which do not contain alpha hydrogen atoms such as formaldehyde or benzaldehyde undergo mutual oxidation and reduction on the treatment with concentrated alkali. See, some of the examples like formaldehyde and benzaldehyde, they doesn't have at least one alpha hydrogen also. That's why it will undergo mutual oxidation with the presence of concentrated alkali. The CANNIZZARO reaction is a redox reaction in which two molecules of aldehyde which do not contain alpha hydrogen atom are reacted with strong alkali to produce a primary alcohol and a salt of carboxylic acid. This is aldehyde reacted with alcohol to form salt of carboxylic acid and primary alcohol. Here formaldehyde, this is also formaldehyde. In the concentrated potassium hydroxide will form methanol and potassium formate. Here if you see benzaldehyde treated with concentrated sodium hydroxide, benzyl alcohol and sodium benzoate. What they have told, primary alcohol and salt of carboxylic acid will be formed. Here this is primary alcohol methanol, this is benzyl alcohol, and here you have seen. This is very important reaction where the aldehyde, aliphatic and aromatic aldehyde like formaldehyde and benzaldehyde respectively, which does not have single alpha hydrogen also, then what will happen? You can see it will happen through redox reaction and it will form primary alcohol and salts of carboxylic acids. Next, electrophilic substitution reaction. Aromatic aldehydes and ketones undergo electrophilic substitution at the ring in which the carbonyl group acts as a deactivating and meta-directing group. For example, benzaldehyde when reacted with nitrating mixture called nitric acid and sulfuric acid at 273 and 283 Kelvin, meta-nitrobenzaldehyde will form. At the meta position, nitro product group will be there, so meta-nitrobenzaldehyde will be formed. Uses of aldehydes and ketones. In chemical industry, aldehydes and ketones are used as solvents and strong starting materials and reagents for the synthesis of other products. This will be used as a starting materials for the other products production. Many aldehydes and ketones, example butyl aldehyde, vanillin, acetophenone, camphor, etc. are well known for their odors and flavors. Camphor you know already, that is a name for odoring agent only. So it will be butyl alcohol, vanillin, acetophenone, these are all flavoring and good odoring reagents. The commercially important carbonyl compounds are methanol, ethanol, benzaldehyde and propanol. Usually the commercially used products carbonyl groups are methanol, ethanol, benzaldehyde and propanone. These are the uses of aldehydes and ketones. And here uses of formaldehyde. From the methanol, how it will be used? Methanol is used in the manufacture of bakelite, resins and other polymers. Usually methanol will be used in polymer industries. Its 40% aqueous solution of formaldehyde known as formalin is used for preserving biological specimen. You have seen in the biology laboratories or zoological laboratories, we will use formalin as a solution to preserve the biological specimen. It will be having the percentage of 40% of aqueous solution of formaldehyde and known as formalin. It contains 8% of methanol and 52% of water. Formaldehyde is used in the preparation of urotrophin, which is used in the antiseptic for urinary infection. Nitration of urotrophin gives RDX a powerful explosive. It is used in the preparation of a medicine to cure urinary infection and also nitration of urotrophin, which will be used as medicine. If you nitrate that one, it will give RDX a powerful explosive also. Formaldehyde is also used as an antiseptic. Next, acetaldehyde, that is ethanol. Ethanol is used in the preparation of number of organic compounds like acetic acid, ethyl acetate, N-butyl alcohol, in the preparation of number of organic compounds. Paraaldehyde, a polymer of acetaldehyde, is used in medicine as a hypnotic. It is used in silvering of mirrors. Okay, that acetaldehyde. Next, acetone, which is a propanone, used as a solvent in manufacture of smokeless powders or celluloid. It is one of the ingredients of liquid nail polish, that acetophenone, which gives the smell, that fragrant smell from the nail polish because of acetone. It is used in stony acetylene gas. Next, benzaldehyde, used in perfume industry, manufacture of dyes like malachite green. As a starting material of synthesis of other organic compounds like benzoyl chloride, cinnamic acid, etc., we know that it is the best starting material to produce other organic compounds. These are the reactions from derivatives of ammonia, also from alpha hydrogens from aldehydes and ketones, and the named reactions, whatever you have seen in this session, they are very much important for the examination purpose, as well as the uses of aldehydes and ketones. In the next session, we will discuss about completely carboxylic acids, its preparation, its nature of bond, and also the reactivities and uses. I hope you have understood completely whatever I have taught in this session. We will meet in the next session. Thank you.